Okay, so linearization, when you see that, you're going to start with y minus y equals m times x minus x. Alright, so I'm going to need my derivative anyway. If it's a free response, I'm going to show I'm taking my derivative clearly. X squared plus 9 to the negative 1/2 times 2x. Chain rule, product rule, quotient rule. You can't ever forget those, okay? My 2's cancel. I've worked with a few of y'all lately, like a good many of you, about bringing the number down in front, looking to see if you can simplify. Like, what are the easiest ways? Sometimes until I'm looking at group work, I don't realize how you're making your life more complicated than it needs to be. These 2's cancel out. It gives me x over the square root of x squared plus 9. Now, I need f prime of negative 4, which will give me negative 4 over, I think that'll give me square root of 25. So my slope is negative 4/5. And then this is just my y value, f of 4, which was the square root of 25, which was 5. I'm working this really fast, so y'all just check me on this. I'm going to add the 5 to the other side. It helps not to distribute. So Mike's trying to tell you easier ways to do things. It's a whole lot better not to distribute that, because when you fill in the number in question, I'm sorry, that's the answer to A. I would just leave it like that, or you can move the 5 over. But don't distribute it, because your life is a lot easier if you fill negative 3.9 in there. Okay, so now watch this. It's an approximation, and they said to use L of X. So I'm going to say L of, that's not an L, L of negative 3.9 is equal to, so I'm talking more today about notation and how you'll be required to write it, which you'll find in the video the guy's talking about how you'll also be required to write L'Hopital's rule. So announce you're doing linearization, and then you have 5 minus 4/5. Show that you filled in negative 3.9 plus 4. But y'all also see it's going to be far easier if you go ahead and leave it in parentheses. It'll always be a number close to 4, okay? So that's going to be 5 minus 4/5. What is that, 1/10? And so I got 5 minus 4 over 50, which if I don't have my calculator would be 5 minus 8 over 100. I think I have worked these. The 4.92, that does sound familiar. Did y'all get 4.92? So what does that mean, class? That means that you would go ahead and write your approximation. So f of 4.92, you would say is approximate, f of negative 3.9 is approximately equal to 4.92. So make sure you say approximately. You've made an approximation. Again, to reiterate what you've done, this graph, I'm not sure what it looks like, so I'm just going to draw just some sort of a graph. I would have to think about it a little bit harder. But you just wrote an equation of the tangent line at a point like negative 4. I should know what this looks like. What's the equation? Y squared. It looks like it'd be kind of hyperbolic. I think it goes both directions like this. But anyway, it's back here. And you write the equation of the tangent line at negative 4. And then you filled negative 3.9 into the line. You didn't really ever fill it into the purple, but you see how close those two values would be. You're not off by much, which is what C is. F of negative 3.9 actually equals what? What does some of y'all get for that? That was our approximation, so it shouldn't be exactly 4.92. Did y'all really do your homework?
I got 4.92, but I got other decimals.
Give me those.
I didn't.
Oh, you need to write them down because you they should. Thank you. 4.9204. So John, that must have been what you got. So you can see how incredibly close it is. Like somebody noticed in one of my H block class, this is growing so slowly out here that means the tangent line's gonna lock onto it pretty good. You know, if something's growing steeper, your tangent line's not gonna be as good as an approximation. Do you see there's a bigger gap? Do y'all see what I mean right along there? Whereas if something's going slowly, your approximation lasts better, longer. I don't know if I'm saying that very well, but you see how it's growing slowly. It touches it. It only touches it once, but it stays really close to it after you've locked it on. Any questions on that? All right, so what did y'all use to approximate root 101 without a calculator? So you'll write the equation of the tangent line where? Please tell me y'all thought through all this, because we're moving on to a new topic. Nobody really knew what they were doing?
You would use the square root of 100.
Thank you so much, Andreas. Thank you for playing, okay? Do y'all all know what Andreas is saying? If you want, you get as close as you can. Thank you, Andreas, okay? So I'm gonna use 100 to write my linearization. So my function is y equals square root of x. Okay? Then you derive it, John, good. So you get 1/2 x to the negative 1/2, which is 1/2 root x. And then you're going to fill in Andreas is 100. So I'm going to have y minus y equals m, which is 1/20, times x minus 100. Please ask questions again because we're moving on to our last topic before the test. You've got to understand linearization and how to pick up what you're going to linearize. Okay? All right. So now I would suggest leaving it in parentheses because then it's easy to fill in 101. So look at what we're doing, class. We're doing 101 into our line, not our actual equation y equals square root of x. So y minus 10, or I'll just say y equals and move the 10 over, plus 1/20 times 101 minus 100. So this gives me 10 plus 1/20 times 1. So that would be 10 plus, I think that's 5 100ths. And so if you did it right, you should have gotten 10.05 as our approximation. Did anybody check and see what square root of 101 actually was? You should have been curious at this point if you're really learning as you're going. I think Olivia's going to check it for us. What is the square root of 101 exactly?
It's 10.04987.
Yeah, so it's 10.05 basically.
Okay. But that's our approximation. That's the real thing,
Yeah.
right?
So it's
So we're just saying, oh, this is really cool because all I'm doing, think about it with me. Couldn't you pull in like a 7th grader to do this? Well, it's just a line.
Yeah.
They might be a little worried about the fraction. They just come from 5th and 6th grade, 4th, 5th, and 6th grade where you were really getting common denominators and good at fractions. So do you see what I mean? Like, if you understand what you're doing, it's very easy. So as you're plowing through your calculus, think about understanding it. Do y'all have any other questions on 4 or 5? Before the test, I will provide the answers to this worksheet so you can check yourself. And we'll come back. We may even do them when I come back and do number 6. Eric, question? Oh, thank you. Okay, so this one looks under because I already know the answer, right? Okay, but let's go in and talk about that. Thank you. What if they said, here, Eric, was it an under or over approximation? Take the second derivative. Thank you for asking that. Class, look up here. I'm always trying to make things easier on you. And sometimes you're just not doing what I say to do. I'm going to take it from here instead of from this cleaned up version. Y'all see it's going to be a little easier to take the second derivative here. So comb back through, look back through and go, where's the easiest spot? Here I can just bring this down and get negative 1/4 x to the negative 3 halves. So that gives us negative 1 over 4x to the 3 halves. Now at x equals 100, or 101 for that matter, can you see that your second derivative would be less than 0?
So that means it's under.
Yeah, well, be careful. cause that's concave down. So it's concave down, so whatever line we wrote would be an over approximation. And it was an over approximation, do y'all see that? Second derivative is gonna be your key, you'll be asked that a good amount. Second derivative is very powerful. Now that's not really what this graph looks like. The graph of square root of x looks more like this. And indeed, isn't it concave down? And when I write the equation, it's an over approximation. It's super close, because class, out to 100, it's almost laying on top of it for a while. It locks on at 100, but it's almost laying on top of it. I know I didn't maybe answer it on 4 and 5, but do you see what you'll always do? Take the second derivative and see what's happening around that point that you filled in. Okay? You can actually fill in the 100. It's a little easier sometimes.
So when after you get the approximation, if the approximation is higher than the number the number that's supposed to be, that's over approximation.
Okay, sometimes you want, like for instance here, they might say approximate, and it could be a non-calculator problem.
Mm-hmm.
So you might not even have this inside information.
So then you use the second derivative
Yes.
to know.
And so if it's concave down, the tangent line if the second derivative's negative, if it's concave down, can you see that it would have been an over approximation?
Yeah.
So if it's concave up, if you get confused, just draw yourself a little picture.
Right.
Kind of miss that.
So if it's concave up, that means it's
under.
Approximation.
Okay.
And then we don't have to calculate.
And so then, obviously you and I can look at that and go, oh, it's an over. But if you don't know that, then they still might ask you.
Okay.
Okay.
Makes sense.
Second derivative's going to tell you that. All right. Thanks for bringing that up, Eric. Okay. So